Hi everyone, this is Revathi M, Assistant Professor, Department of Computer Science, Artificial Intelligence and Data Science, Dr. SNS Rajalakshmi College of Arts and Science. In this series, we are going to discuss about the machine learning. So machine learning is a subset of artificial intelligence that focus on the development of algorithms and models that enables computer to learn and make prediction or decision based on data. So the primary goal of machine learning is to enable computer to learn automatically without being explicit programmed. So in this presentation, we are going to see about the inductive bias in concept learning. So the inductive bias is divided into two types. One is biased and another one is unbiased. So what is concept learning? Concept learning is inferring a Boolean valued function from training example of its input and output. So the inductive bias is a fundamental concept in machine learning as it determines the ability of a learning algorithm to generalize beyond the observed training data. So these articles explores the implications of inductive bias in the context of candidate elimination algorithm, highlighting the trade-off between expressiveness of the hypothesis space and the algorithm ability to generalize. Next, we see the biased hypothesis space. Here, biased hypothesis space, we are having the restricted hypothesis space, inability to represent target concepts, and need for more expressive hypothesis space. We will see one by one. First, restricted hypothesis space. That is defined as the candidate elimination algorithm was initially restricted to a hypothesis space for conjunction of attribute values. This limited the algorithm ability to represent more complex target concepts such as disjunction hypothesis. Next, we see the inability to represent target concepts. So the target concepts, when the target concepts was a simple disjunction of attribute values, the restricted hypothesis space was unable to represent it, leading to the algorithm finding no hypothesis consistent with the training data. Next, we see the need for more expressive hypothesis space. So in biased hypothesis space, we are need for more expressive hypothesis. So to ensure the target concept is contained in the hypothesis space, a more expressive representation is required, such as allowing arbitrary disjunction, conjunctions, and negation of attribute values. Next, we see the unbiased learners. So in unbiased learners, we are having the hypothesis space expansion, inability to generalize, anonymous voting futile. We will see by one. First one is a hypothesis space expansion. So by expanding the hypothesis space to the power set of the instance space, the learner can represent any possible target concepts. Here, this eliminates the problem of the target concepts not being expansible in the hypothesis space. So it is the inability to generalize. So inability to generalize is this unbiased hypothesis space leads to a new problem. The learner is unable to generalize beyond the observed training examples as the version space will simplify with the distinction of the positive examples and the negation of the negative examples. Next, we see the unanimous voting futile. So it is defined as the attempting to use a voting mechanism among the version space hypothesis to classify new instances is also futile, as each unobserved instance will be classified positive by half the hypothesis and negative by other half. So first half is the first half of the hypothesis is positive and the another half of the hypothesis is negative. These are the unanimous voting futile. Next, we see the why we need inductive bias. So, a learner that makes no a prior assumption regarding the target concept has no rational basics for classifying unseen instances. Inductive learning requires some form of inductive bias. So inductive bias is the set of assumptions that allows the learner inductive inferences to be justified deductively. It is the additional assumption needed to transform inductive inference into the deductive ones. Next, we see the inductive bias of candidate elimination. So the inductive bias of the candidate elimination is the assumption that the target concept is contained in the given hypothesis space. It represents the H. So next we see the inductive bias and generalization. So the both inductive bias and generalization, we need the target concept, hypothesis space, inductive bias and generalization. First, target concepts that represent the learning algorithm is trying to learn. So next one is the hypothesis space. So it is a set of possible hypotheses the algorithm can consider. So next one here, inductive bias. So here the set of assumption that allows the algorithm inductive inferences to be justified deductively. So another one is a generalization. So the algorithm ability to classify unseen instances beyond the observed training data. So we come to the end of this section. So inductive bias is a fundamental concept in machine learning as it determines the ability of the learning algorithm to generalize beyond the observed training data. I hope you enjoy this session. Thank you.